All right, we got another check yourself problem here. This one is on target 2.2, which deals with your ability to apply kinematics problems, or I should say use kinematics equations to solve word problems. That's a much better way of putting it. So here we've got a problem for you to solve. So it says a baseball hits a catcher's glove while it was traveling at 37 meters per second. The catcher's glove moves backwards 5 centimeters. How long, much time? So let's get rid of that. How much time did it take the catcher to stop the baseball? So that's what we're going to try and figure out. Okay? Now, I want you to try this on your own. Do your best. Forget the rest. A la Tony Horton. If you don't know who that is, Google it. And come back, see what the answer is. All right, so just you should be doing work now. Okay, well, this is the answer over here. Okay, here's the answer. The correct answer is. So again, if you're not working on it, you should really work on it instead. Pause this video. All right, you ready? All right, that's the answer. Okay, that's the answer. So if you did not get that answer, then you're going to watch this. Okay? So here we go. First hint. In a second. Okay, just a second. So I'm assuming you're pausing this. Bam! Did you list your givens? Because if you didn't get the right givens, if you did not list your givens, that's not going to work out for you. Also, you'll notice that I was evil. Yeah, it happens time to time. And that's the centimeters, but you want that to be meters, so you got that conversion. So that might have also tripped you up. All right, so that being said, look at what your givens are, see if you can pick the right equation, do the rest of the steps to get this thing done. All right, so go back, give a second shot. I'm going to start walking you through how to solve it, so if you want to give it that second shot, pause the video. If not, you can kind of see me just kind of walk through this. All right, so I'm going to start now. I'm serious. All right, well, there we go. We list our givens. We now need to pick the equation. All right, so we've got our list of kinematics equations. So this one, because remember, our kinematics equations are these. So we've got delta x equals v sub naught delta t plus 1/2 a delta t squared. Delta x equals 1/2 v plus v sub naught delta t. That's the letter A. I have no idea what happened with my brain there. There we go. We have this guy. And we have this one. All right, so those are our 4 kinematics equations. So basically, you're going to say which one of these matches those guys. And so for equation, the one to use is this one. Delta t. And then once you have that, it's going to have substitution and solving. So put them where they belong. So my velocity slows down. Why did I put that there? I'm having a day. Having a day. You ever have a day? Just like brain's not working quite right. You know it. So there you go. Now it's I'm doing algebra. All right. So multiply by 2, divide by 37. You get yourself an answer of 0.0027 seconds. In the blink of an eye, the catcher caught the ball. All right. Now you can double check yourself with a graph as always. So I'm just going to quickly sketch that graph out. So if you want to draw, I always draw velocity time graphs. They're much more helpful. So your initial velocity was there. What is, no, velocity is down there. You come to a stop. And so we need to know what this time is. We actually know the displacement right here. Delta x equals 0.05. And we know this is 37, goes down to 0. So we could calculate acceleration, and then knowing that, we could calculate time. Or we could just say, hey, displacement equals area. And we know this is 0.05 equals 1/2 base times height, 'cause it's a triangle, and the base is time, and the height is 37, and solve for that and get the exact same answer. So could do that as well. So there's ways to solve this problem. So hopefully you got the right answer. Hopefully you see the error of your ways if you did not. And yeah, hopefully that'll prep you for the assessments. Bye-bye.